Hello everyone, welcome to the video. In this video lecture, we'll be discussing about the queue data structure, and we'll be discussing that how we can have an array implementation of the queue, how we can implement the queue using an ordinary array. So what is a queue? Queue is a very fundamental and important data structure for computer science. To understand it from the real life concept, think like you are in the drive-through, you want to buy a burger from McDonald's, and you went into the drive-through. There are multiple cars in the line, and then you entered from one end. You entered from the rear end of the queue, and then the person that is at the front of the queue will move out first, and then you will move forward. So the person who is getting first into the queue will get out from the queue first. That is why this queue is called a FIFO structure. We call it FIFO, meaning that first in, first out. The element that is coming first in the queue will go out from the queue. The second point is this queue is a two-ended data structure. Unlike stack, stack is only one-ended data structure. So queue is a two-ended data structure, meaning that we have two ends. One is called the rear end, from where you can enter into the queue. Another one is called the front end, from where you can exit from the queue. So think like it is an array. I mean, even if you think as a McDonald's, the number of cars that are in the queue, they have a particular number, right? So the first car, second car, third car, fourth car, they all are placed in the contiguous memory location like an array. So think like this array is as a, let's consider this as a queue, this array as a queue. So it has two ends. One is this end, from where you are going to enter the value. Let me call it a rear end, from where we are entering into the queue. And the process of inserting the element into the queue is called enqueue, right? So we call it an enqueue process. We want to insert the element in the queue. And this is another end from where the elements are moving out, the elements are deleted from the queue. This is called the front end of the queue. And the process of deleting or taking the element out from the queue is called dequeue process. So we actually remove the elements from the queue with this dequeue process, right? So with this foundation, with this understanding, let's write the Java class for queue through the array implementation. By the way, we can implement this queue through either with an array, right, or as well as with the linked list, right? So in this video, we'll be discussing about the array implementation of the queue, and in the next video, we'll be discussing about linked list implementation of queue, right? So what do we require in the number of elements in terms of variables and the methods for a queue? Let's understand it now. So we require one array that we will consider as a queue, right? So we'll require, let me just mention it over here, we require one array, right, that we will be considering as a queue. So in order to maintain the whatever is the front and whatever is the rear of the queue, will require one front variable that will point to the front position of the queue. Will require one rear variable that will point to the rear end of the queue, meaning that it holds the index number of the rear position of the queue, right? So we require one variable called size that will actually tell the size of the queue, and one more variable, say capacity, right? So capacity will tell me what is the maximum capacity of the queue. The difference between size and capacity is, say the capacity of the queue is 15, it can hold 15 elements, and how many number of elements are present in the queue is the size. There are 7 elements, so 7 is the size, the capacity is 15, so they differ in that means. And the second point here is, what methods do we require in order to implement this queue? One method is very obvious that we require is enqueue, right? So we require this enqueue method to insert the element. We require the dequeue method to remove the element from the queue. We require is full method to check whether the queue is full or am not. We require is empty method that we will use to see whether the queue is empty or not. We require peek method that will just return the value at the front of the queue. So the difference between dequeue and the peek is like the difference between pop and peek. So dequeue will decrease the size of the queue and will remove the element from the queue, whereas peek will simply return the value in the queue. Similarly, we'll be using some more methods like get size method and so forth. The point to understand here is all these methods like enqueue will have the time complexity of big O of 1. The dequeue will also be having the time complexity of big O of 1. Is full, is empty, peek. All of these methods will be executing in big O of 1 time. Right? So with this foundation, let's just jump into Eclipse and let's write some code so that we can see how we can implement the queue in Java. So first of all, what variables do we require? We require an integer type of for front, for rear, for size, and for capacity. Right? And we require one array of what type. So let's make it generic. So I'm going to define my own user-defined data type. The generic data type says suppose T. So I'm going to declare a T type of array, right? Q with the name Q, right? So that's the variables that we have. Now let's write one constructor for this Q class where we will be initializing those values. So for example, I'm going to have an argument constructor public Q, and that is going to receive integer capacity that the user wants to actually give the capacity that he or she, the user wants to have the capacity of 50, right? The Q of 50 capacity. So that's what first of all, what we need to do here is I'm going to say this dot capacity is equal to the capacity that we have received as an argument. And at this point, front and rear both are pointing to the 0th index. That's my understanding, right? So what we are doing here is, okay, this is a spelling mistake. Let me just correct it. So front and rear both are pointing to the 0th index. Let's see. And then I'm also making the size is equal to 0, right? So what happens is when I will now create a queue. So what will be happening? Let me just simulate it at the same time so that we can see what's going to happen. So we'll be having a variable with the name front, right? That is going to have 0. We'll be having a variable rear that is having 0 value, and the size is also 0, right? So that's the current situation at the moment. And the capacity is the value that the user has entered. Say suppose a user has not given any capacity. So can we have a default constructor or the default size of this? Let me write one more constructor Q with a no argument, that is a no argument constructor, and I'm going to call the argument constructor by passing 5, for example. So I'm going to have a default capacity of 5. So what does this mean is if in my runner class or in my tester class, if I create the object of this Q, right? So for example, Q is equal to new of Q. So if I do not pass anything as a capacity here, it is going to declare this array of size 5. If I pass 15, it will create the size of the array of size 15, right? So let's say now once we have that, okay, so now let's write some methods for enqueuing the data into this queue. Let's say how we can do that. So public void enqueue, we won't be returning any value, right? So enqueue, it accepts a T type of data that we want to insert in this queue, right? At the in the queue. So where the data is going to be inserted in the queue, we know that it is going always in the queue. The data is placed at the rear end of the queue. Keep in mind the example that I have given you in the McDonald's drive-through queue, right? So you are going to get at the back of the queue, at the rear of the queue. So what I can do is I can simply say Q, that is my array of rare, is equal to data that we have received, and then increment the rare, right? Rare is equal to rare plus 1. Also increment the size plus plus. So after doing this, what's going to happen is now, so suppose you say you entered 5 into the queue. So 5 will be, so right now the rare is pointing to 0. So 5 will be placed here, and rare will be incremented to 1, right? And size will also be incremented to 1 now. That makes sense, right? And that's it. What we have to do. What else we have to do? So let's say, just let me put some values in. Call this Q method, Q.nq, right? So we did some mistake here. We have to make these variables private variables so that no one can access it outside this class. Okay, so Q.nq says suppose 5. So after doing this, this will be the position of the queue. Once again, Q.nq. So suppose I say hi, right? So this is a string type of data, but since it is a generic queue we have defined, it will accept that data. And after doing this, what will be the position of the queue is simply, it is going to the rear end. Rear is pointing to 1 now. It is going to add right high here at this position and will increment to the rear. So rear will now point to the second position, right? So after doing this, let's say, for example, if you write Q.nq 5.9, right? So what will happen after this line of code is again the same thing. Rear is pointing to the second position. It will write 5.9 at this position and will increment into the rear. So rear is going to point to the 3 now, and size will also become 3, right? That's how we are going to simply add the values into the queue. Now, let's say, for example, if I want to see what are the elements in the queue, let me just write one more method to print the values of the queue. Say how we can do that. Public, say suppose void print. I want to print the values of this queue. So that is very simple. I can simply run a for loop for an integer I that starts with 0. I is less than the size value and I plus plus, right? So inside this loop, we can simply print out the values is out. For example, the queue of ith index plus a comma and space, so that we can see the values separated. And after coming out from the loop, I'm just going to change the line so that we can see the next output on the next line. So if in my runner class, in tester class, if I call this print method, it is going to print the values of the queue, whatever we have, right? So right now we are going to get the null pointer exception. The reason why we got this is, so we are getting error over here. The reason is we have not yet initialized this queue array. So we have declared this queue array, but we haven't initialized it. That's one of the biggest mistake that we have done. So inside this queue constructor, I'm going to initialize it. So what I'm going to say is queue is equal to new of object of capacity, right? So we already have seen that how to create the generic type of array through the object, right? Object array. So I'm going to typecast it to T. If you are unaware of that, so you can see my previous videos on how to create a generic data type in Java, how to use the generic data type, right? Okay, after doing this, let me run this code. Now it will be all fine, and we have 5 high and 5.9 in the queue, right? Let's say, for example, if I add one more value, Q.nq 11, so 11 will be added after 5.9. That makes sense. Let's say, for example, if we have one more value, Q.nq, say suppose 21. So 21 will be added at the rear end, meaning that after 11. So my data is being added into the queue. We are able to write nq method. Now, what happens? What will happen if I add one more element into that. So my queue capacity is the default capacity, right? So let's say, for example, I'm going to write 25. So my queue capacity is the default capacity. That is what? That is 5 that we have passed here. And this array was created for 5 positions only. So once we have the 5 positions only, and we have 1, 2, 3, 4, 5 NQs that we have printed already. And what happened when we have the next element? So remember, at this point, my rear is pointing to the index number 5. That is not part of this array, right? That's not part of this array. So obviously, we are going to get array index out of bounds exception here. Let's see, we are going to get the index out of bounds. That 5 is out of this array. So what does this mean is, once my queue is full, I am getting this error. So can I do something to prevent this exception? Yes, we can do that. Let's write one more method here first. Let's say, for example, public boolean is full. So I will be using this method if the queue is full. I do not want to add more values, right? So this will return either true or false. How we can check the queue is full? That is very easy. We can simply return the value true only if the size is equal to the queue dot length, right? Queue dot length or the capacity. We already have the capacity variable, so we can check the capacity, right? If the capacity and the size becomes equal, meaning that we cannot accommodate more elements. And the good way is to have one more method that will return an integer, get size. This will simply return the size value. And here now you can use this get size method, right, instead of the simple variable. So now if I'm going to do that in my enqueue method, before simply initializing the value, what I will do, I will check, do this only if the queue is not full. So I'm going to check if not of is full. If the queue is not full, then only do this work, right? So what I'm trying to say is, if the queue is not full, then place this data to the rear end of the queue, increase the value of the rear, increase the size of the rear. And then I'm going to simply return from here. I'm done. I have to return from here. If this if condition is not true, meaning that the queue is already full, that you can throw an exception, right? Throw, for example, a new of index out of bounds exception, right? That you can throw by passing a message, for example, queue is full. So you can simply throw this exception. Now, instead of having some runtime error, the user will handle this exception in its tester class. Like, for example, here, see, we are getting this error right now. Once after adding this code, if you run that, it says it is queue is full, and we are getting an exception. That actually we can handle over here in my main program by simply using a try and catch block, right? Try and catch block, that we can catch the exception, for example, E, then you can, in the catch block, you can simply print out whatever you want, or you can use it, whatever is the E dot get message, right? Get message. So this will now simply print that queue is full instead of giving you the runtime error, right? Even if you do not want to run a try or catch block in the main, the user will at least get to know that what's going to happen, right? Okay. Now, let's write a code for DQ, right? You can actually, in the enqueue, in the else part, you can print a message over here, but that's not a really professional way. It's a professional way is to throw the exception, and the user can handle that. Now let's write the message for dequeuing the element from this queue. Let's say, for example, public, this is going to return you the T type of the value DQ, right? So in the DQ process, what we have to do. So first of all, in the DQ, what we need to do is we need to check. We are going to return the values for, let me say, I'm going to create a D type of data, that, so we know the value that we are going to return, that we are going to store, is at the front of the queue. So I'm going to say queue of front, right? Put the values, whatever is in at the front of the queue. Once I have that, right? Once I have that, what I have to do that, I simply can increment the front, right? Understand this, at this point, while you're having this situation, right? Like, for example, you have 5 at 0th index, high at the first index, 5.9 at the next index, 11 at this index, right? So you have 11 at this index, and then you have 21 at this index. And your at this point now, your rear is pointing to 5, right? And the size is also 5, right? And front is still at 0. So what we can simply say, we can return the value whatever is at the front of the queue, that is in fact 0, right? At this point, whatever is the current situation. So if we do that, what's going to happen? Let's see. What we can do is we can simply say that size, okay, we can simply increment front is equal to front plus 1, so that we can move the front to the next pointer. So the next time whenever the DQ is called, it should return the value at the index number 1, right? And similarly, size minus minus, it is going to decrease the size out of that. And then we can simply return this data. That's it. We are done, right? So, okay. What is the error we are getting here? Okay, public. Right, so we are done. So now, for example, here, if I, after entering these values, I'm going to print this, right? So this is the current situation of the linked list. Now, after printing this, if I say q.dq, you can actually, this dq will return you a value that you can handle in some variable, or you can directly print it out. But if you don't do that, it will simply discard that value. So if I dq the value and then again I call the print method, so what will happen? The 5 is at the front of the queue, that should go out, and rest of the list will be printed. So, but we are getting wrong here, right? So in fact, we are getting, the 21 is not printed. So it should start printing from high until 21. So what's wrong? The wrong is with this print method, because print, we are starting from 0 until the size, and we are printing the ith value of the array. So instead of printing the ith value, now I am going to print the front plus ith value, so that we can get the actual result. So see, this time we are going to get the, this 5 is gone from the queue after calling this DQ method. Let me call one more time this DQ method. This time this high should go out from the queue, and rest of the values will be printed, that is starting from 5.9 until the end of the queue. All right. Okay, say suppose the same thing, if the queue is already empty, we make it empty. Let's say, for example, q.dq, q.dq. So now we enqueued 5 element, we dequeued 5 element. So the queue is empty, nothing is being printed for the second print call, right? Now, after that, if I call q.dq again, so obviously again you will be saying, you can imagine front is pointing to the index number 5 that is not in the queue. So that means you are going to get this index out of bounds exception, right? Every time we are incrementing this front pointer as we are calling this DQ, right? Here you can see in the DQ method, we are incrementing the front. So that means before doing this, what we need to do, we have to check whether the queue is not empty. If the queue is not empty, then only we can return the value. If the queue is empty, we cannot return the value. So let me write another method here. Let's say, for example, public boolean is empty, right? So is empty will return me the value true if the queue is empty. And how can I get that the queue is empty? Obviously, we can check it with the size. If the return true, if get size is equal to 0, that means this queue is empty, right? So that means what I can do here is, before doing this all, what I can do is I can say if not is empty of this. If the queue is not empty, then only do this stuff. Otherwise, if the queue is empty, throw an exception, like we did in the in the enqueue method, throw new of no such value, no such element exception, right? No such element exception, and you can pass the message queue is empty, right? So that you can actually use, right? And then you have to import this no such element exception from the java.util package. That's it. So now let's say, for example, if I'm going to dequeue it, it is going to tell me that there is no such element, right? The queue is already empty, right? So if you do not have this dequeue call, it's going to dequeue all the elements from the queue, and queue is going to be empty, right? But if you on the empty queue, if you are going to make a call to the dequeue, you are going to get the exception that you can actually put it in a try catch block, or you can throw the exception using the throws clause, whatever, right? So now we have successfully done that. So what happens is, say suppose, let me just make few more changes like here. So this is the current situation. Now we have enqueued 5 elements into the queue, and we have dequeued 3 elements out of the queue, and it shows there are remaining 2 elements, that is 11 and 21, right? Okay, now what at this point, what is the situation? What is the situation of the queue here is that my front is pointing to 11, front is pointing here, right? Front is pointing here, and rear is pointing to this position, right? This position, that is out of the point, right? Rear is pointing this one. So what is the capacity of my queue? Capacity of the queue is 5. So what is the size of the queue? The size of the queue here is only these 2 elements, 11 and 21, right? You can see it over here as well. Okay. So what happens if I try to add one more element into the queue? Since this capacity should allow me to do that. Like for example, after print, if I say q.enqueue, say suppose 50. So ideally it should add 50 into the queue. But what happens is my rear is pointing to a position that is not in the queue, right? And in the enqueue method, what we are doing in the enqueue method, we are saying, whatever is the rear value, put this data onto that position. So obviously you are going to get the array index out of bounds exception once again, right? But that's not correct. That shouldn't be happening. The reason is because the capacity, the size is less than the capacity. So what should I do so that we can have this element in the queue now? So we can use a circular array, right? Instead of simple array, we can make this array circular array, right? So that we can do that. So what does it mean is, so for example, logically understand it, then I will be explaining this whole concept in the Java code. So say suppose you are going to have a circular array, like it's just a conceptual circular array. In reality, it is the contiguous memory location in the memory, right? So for example, you are going to have the array like this one, the 0th index, right? And this is, for example, your index number 1. This is the index number 2, index number 3, and index number 4, right? So the front is pointing to the 0 index, right? Front is pointing to the 0 index when this this queue is created and queue is empty, and rear is also pointing to the 0th index. And then you call the enqueue method and you want to add 5 will be placed here, rear will be incremented, and rear is pointing to this position now, right? So rear is pointing to this position, rear is no more pointing here. And then when rear is pointing here, so what happens is next time when you call the enqueue once again, so suppose you entered 7 in the queue, so the rear is pointing to the next element, that is this one. This time you entered another value, like for example, let me just erase this all together. And so for example, this time you are going to add the value at the rear end. For example, 9 is going to be placed here, right? So 9 is going to be placed here, and then you can actually put the values there. And then what does this mean is, the next time this pointer, the rear is pointing to the next position, that is position number 3. And when you have entered 15, 15 will be placed here. right? And then this rear is going to point to this next position, that is this one. So for example, 20 will be placed here when you add one more element, right? So in that case, now, say suppose you dequeued at this point, you dequeued some element. So if you dequeue this 5, you called 5, right? So front will move forward and front will be pointing to the index number 1, and this will be right. So this will be, front will be pointing to the index number 1, right? Okay. So now, so for example, you try to enqueue one more element now. So since the space is available, for example, you try to enter 27 this time, you try to enqueue 27. So 27 should go at the 0th index. It shouldn't go at the index out of bounds to the index number 5, that is not part of the array. So what do I mean is, once we reach to the last index of the queue, we can make it circular by sending the rear pointer back to the 0th index, right? And how we can do that? We can achieve it through the mod operator, simple mod operator, right? Like instead of simply saying, like for example, if I say the side, the rear, and if I take the mod with the capacity, we can do that. Like for example, the rear is pointing to 0 and the capacity is 5. 0 mod 5 is going to return you 0, and 0 mod, sorry, 1 mod 5 is going to return you 1. 2 mod 5 is going to return you 2. 3 mod 5 is going to return you 3. 4 mod 5 is going to return you 5. And if I take, sorry, it is going to return you 4, right? And then if you take 5 mod 5, it's going to return you 0 again. When rear is incremented, rear becomes 6. 6 mod 5, it is going to return you 1. And rear is incremented, rear is 7. 7 mod 5, it is going to become 2 again. And rear is incremented, 8 mod 5, it's again 3. 9 mod 5 is becoming 4 again. And then if you say 10 mod 5 is going to return you 0. 11 mod 5 is going to return you 1. So meaning that if I use this mod operator, I can actually navigate from these. I mean, after reaching at 4, I can send it back to 0 again, right? After we reach at 4, we can send this rear back to this 0th index. We can send this rear back to the 0th index instead of the index out of bound, right? Now let's see how we can do it in Java, how we can implement that in Java. So that is again now very simple. Instead of doing this simply rearth element, what we can do is we can say rear mod capacity, right? Whatever is the capacity of the position of this one, we can simply do that with that, right? So okay, so instead of putting this here, we can actually move the, we have to move the rear pointer. So I'm going to say rear +1 mod capacity, right? That's all. And the same thing that I'm going to do is with the front, because once we have this front end reached, so for example, you have dequeued all the element and front is now pointing, front is pointing to this index 4. Now, after index number 4, it is pointing for, we have to move this front back to 0 again, right? So how to do that? Again, the same logic we can do. What we can do is, instead of moving this front +1, we can say front +1 mod capacity, right? So this will actually move it to the 0th index, to the beginning of the array again. And that's all, we are done. But once you are going to the print method, again, you will be getting the exception, because front is simply printing the front +I, and I is starting from 0, and it is going to keep on moving that. So instead of simply doing that, I'm going to say front +I mod capacity, so that we can either move it back to the 0th index again. So when you will do that, and if you reach here now, if you run this code, you will be able to see that this will actually insert 50. Let me just call the print method so that we can see the 50 is inserted after 21. Now, say suppose I enqueue one more element, enqueue, say suppose 55. 55 will be enqueued after 50, right? And if I enqueue one more element, say suppose I say q.enqueue 60. So 60 will be enqueued after 55. Now the capacity of this queue is full. Now if you try to insert one more element, say suppose 65, you will be getting an exception, right? 64, for example, you are going to get an exception because the queue is full. So assume that the queue is not full, right? And you dequeue one element, q dot dequeue. So if you dequeue one element, so the first element that was in the queue 11 is dequeued, right? That element is no more in the queue, and the size becomes 4 again. Now, if you want to enqueue once again, it will allow you to enqueue the element into the queue, right? That is going to be placed after 60, right? So that's how we are going to use this code about this enqueue, dequeue is empty and is full, right? And now let's write one last method about peak. So how we can return a peak method again. So let's say public t peak. It's going to return a value of type t, and we have to do the same stuff that we are doing in the queue, except one thing. And that one thing is we are not incrementing the front and we are not decrementing the size, right? Rest of the stuff is same, right? So let's just test it over here. So suppose if I say sys out q dot peak, so it is going to return you the value at the peak of the queue, that is 21, right? And if you call a dequeue method before that, so this time it is going to tell you 50, right? Because 21 is already out from the queue. All right. And one important thing to note here is all these methods, the running time complexity of all these methods are just big O of 1, right? Okay, so that's all about this video. We'll be back with the new video with linked list implementation of queue. Take care. Bye.